where we're going to review the laws of exponents and then get into some work with polynomials. Remember, I said tomorrow you guys are going to write that MIPI test. It's just a diagnostic test to really inform us at the school what you remember from your previous math courses. So it will not be on your report card, Mark. It won't be part of Power School. It's just information that we collect, and it's also sent to central office. So that'll be tomorrow. Okay. So the laws of exponents. So the laws of exponents are a way for us to simplify some expressions that involve exponents. So if you have something like x to the power 2, that is an example of a power. This whole thing is a power. And it is made up of two parts. You're going to have the base, and you're going to have the exponent. The base tells you what is being multiplied together. The exponent tells you how many times it's multiplied together. So x to the power 2, or x squared, means you're multiplying x by itself twice. So part 1 of this, where we're developing the product law for exponents, says to simplify x squared times x cubed by writing it in expanded form. And that would look like this. X squared means you're multiplying x times x, and then that's being multiplied by x cubed, which is x times x times x. So again, this one there in a different color is a multiplication. The other ones are x's. So that would be that expression written in expanded form. And if we look at this, what we see is we're actually multiplying x together 5 times, so that could be written as x to the power 5. That is equal to what we started with, x squared times x cubed. X squared times x cubed is the same as x to the power 5. It's just simplified. So we can do the same thing with question 2 to simplify that expression by writing it in expanded form. So b squared is b times b times another b squared, another b times b cubed. Multiply b by itself 3 times. And so in this case here, we're multiplying b by itself a total of 7 times. So that's the same thing as b to the 7th. And that is equal to what we started with, b squared times b cubed. So then it says, is there an easier way to multiply expressions that have the same base without actually expanding? And the answer is yes. You might remember. When you're multiplying powers with the same base, the law says that you add the exponents and keep the base the same. X squared times x cubed is x to the 5th because 2 plus 3 is 5. Add the exponents, keep the base the same. B squared times b cubed is b to the 7th, because if we add the exponents together, 2 plus 2 is 4 plus 3 is 7, you get b to the 7th. So the easier way is to add the exponents and keep the same base. That's the product law of exponents. It's a way for us to simplify expressions that have multiple things together that are multiplied with the same base. So we can do the same thing to develop a quotient law. We can simplify x to the 6th divided by x squared by rewriting in expanded form. X to the 6th means you're multiplying x by itself 6 times, and that's divided by x squared, which is multiplying x by itself twice. And now we can simplify. We can divide top and bottom by x once. So essentially we're dividing the first x by itself, which leaves us a 1 there, and the second, or the first x on the bottom by itself. And when you divide something by itself, you'll get 1. We can do it one more time, divide that x by itself and get 1, as long as we divide an x on the bottom by itself and also get 1. So what are we left with here? We're left with multiplying x by itself 4 times, which is x to the fourth over 1, or x to the fourth. And this is the same thing as x to the sixth divided by x squared. We can do the same thing for part 2. A to the fourth divided by a to the fourth is multiplying a by itself 4 times over 1a on the bottom. And like we did in the previous one, we can divide top and bottom by the same thing. In this case, we're dividing top and bottom by a, or dividing the first a on top by a, which leaves you with 1. The a on the bottom by itself, which leaves you with 1. And so we're left with a times a, which is a cubed. And that is the same thing as a to the fourth over a, which is a to the 1. And you might remember the simpler way of doing this when you're dividing powers with the same base, you subtract the exponents and keep the same base. For this x to the sixth divided by x squared, if you subtract 6, take away 2, you'll get 4, keep the same base, x to the fourth. For the second example, a to the fourth divided by a to the 1, subtract the exponents. 4 minus 1 is 3, and keep the same base. So again, the rule here is that we subtract the exponents and keep the same base. So that is the quotient law. Quotient means division. You're dividing powers with the same base. And these last sets of examples simplify x cubed all to the power 2 by rewriting it in expanded form. So x cubed is x times x times x. That's 1x cubed, but we need another one because of the squared outside here, which means you're multiplying what's inside the bracket by itself twice. So there's the first one, and here comes the second one. That shows multiplying x cubed by itself twice. If we count up all those x's, there are 6 of them. So that is the same thing as x to the sixth, which would be equal to what we started with, x cubed all squared. And then a to the fourth all cubed, so there's 1a to the fourth times a second a to the fourth times a third a to the fourth. Altogether, there are 12 a's that are multiplied together, so that's the same thing as a to the 12, which is equal to a to the fourth all cubed, what we started with. And so when you look at these two examples, and you might remember, whenever you have one power raised to another, you multiply the exponents and keep the same base. This is known as the power law for exponents. So that is the power law for exponents. And again, these 3 laws are used to help us simplify expressions when we're dealing with powers that have the same base. You with us, Keen? You're not dreaming about girls in bikinis, are you? Oh, I saw you looking at those pictures last semester. So there they are on the next page at the top. The product law says if you're multiplying a to the m times a to the n, you add the exponents and keep the same base, a to the m plus n. The quotient law says when you're dividing powers with the same base, you subtract the exponents and keep the base the same. A to the m divided by a to the n is a to the m minus n. And the power law says if you have one exponent raised to another, you multiply the exponents and keep the base the same. So again, these are just rules that we can use to help us simplify expressions involving powers with the same base. So these questions ask us to simplify. We're going to look and see what the question is and apply the appropriate law. For the first one, you're multiplying powers with the same base. The law says you add the exponents and keep the base the same. So this would be the same thing as x to the 3 plus 7 or x to the 10. Now I don't expect you to write x to the 3 plus 7, but that's what's happening. When you multiply powers with the same base, you add the exponents and keep the base the same. Question B, you're dividing powers, so you subtract the exponents and keep the base the same. And this only works because the bases are the same. They both have a base of d. 8 take away 3 is 5, so you get d to the 5th. Question C, you have one exponent raised to another. That's the power law. You multiply the exponents and keep the base the same. So that's a to the 3 times 2, or a to the 6th. So again, I don't expect you to write the a to the 3 times 2, but that's just what's happening. Oh, I don't know why I changed the base. Should be base m. Okay, so looking at question D, dividing powers, so you subtract the exponents and keep the base the same. 13 take away 7 is 6. Question E, you're multiplying all those together. They all have the same base, so you add the exponents and keep the base the same. An important thing to remember, though, is that that last factor of d is d to the 1. We have to include adding 1 when we add all our exponents together. 4 plus 4 is 8, plus 2 is 10, plus 1 more is 11. That last d is d to the 1, so you have to add 1. Question F, I will do this in 2 steps. I'll simplify the top first. Again, remember that last factor of y is y to the 1. So when you add all the exponents on the y's, 3 plus 2 is 5, plus 1 more is 6. So y to the 6 is then divided by y to the 4th, and now we will subtract the exponents and keep the base the same. We get y squared. Question G, using the power law, the top will be b to the 5 times 3, which is b to the 15th. And now we're dividing powers with the same base, so we subtract the exponents and keep the base the same. 15 take away 4 is 11. Question H, I'll use the power law on both the top and bottom as my first step. And then I will divide these two by subtracting the exponents and keep the base the same. 18 take away 12 is 6, so x to the power 6. Okay, try those next 3 on your own, then we'll check them. So Allie, what'd you get for the first one? You agree with that, Brody? Yes. Got to remember to add that last one. The last factor of m is m to the 1. Question B, I'd probably do that in 2 steps. Simplify the top first by adding the exponents. 4 plus 3 is 7 over x squared, and now we will subtract the exponents because we're dividing powers with the same base. 7 take away 2 is 5. Base stays the same. Question C, again, I'd probably do that in 2 steps. Multiply the exponents on the top. 3 times 6 is 18. So it's a to the 18 divided by a to the 10. And now we're dividing powers, so we subtract the exponents and keep the base the same. A to the 8th. Okay? So let's review a little bit about what you learned before about algebra. It's a branch of mathematics in which symbols, usually letters of the alphabet, represent numbers or members of a specified set, and they're used to represent quantities and also to express general relationships that hold for all members of the set. So there's some definitions there. What is a monomial? Well, a monomial is a polynomial of one term. A polynomial is any expression that has at least one variable somewhere. Okay, that's a polynomial. So all of our answers that we got on the previous pages were examples of polynomials. But they were a special type of polynomial that only had one term, and that's what a monomial is. A monomial is a polynomial with only one term. A binomial is a polynomial that has two terms. So an example of a binomial might be something like 2x plus 3. As long as it has a variable somewhere, it is a polynomial. In this case here, there's two terms. The first term has a variable. The second term, the positive 3, doesn't. It's known as a constant. But as long as there's a variable somewhere, it's a polynomial. And if there are two terms, we call that a binomial. A trinomial is a polynomial that has three terms. So an example of a trinomial might be something like 5x squared minus 4x plus 1. Three terms. Notice that the terms are separated by a plus or a minus. As long as there's one variable somewhere, it's a polynomial. In this case, we have two terms that have the variable x. The first one, the x is squared. The second one, it's not. Ascending order is when things are arranged from lowest to highest. Whereas descending order is arranged highest to lowest. And the reason we talk about that with polynomials is that normally polynomials are arranged with the highest power first and then the next highest power and so on. So if we look at this example I wrote for the trinomial, there are three terms there. The first term is 5x squared. The power on the x is 2. That's the highest power for this polynomial. The next highest power after power 2 would be power 1, which the middle term is x to the power 1. And the last term doesn't have an x at all. So that polynomial is written in descending order of power. And normally that's how we write our polynomials. Like terms are terms that have the same variable with the same exponent. So these are terms with the same variable or variables with the same powers. And the reason we talk about like terms is we're going to see here that Only like terms can be added and subtracted. In order to add and subtract terms together, they have to have the same variable with the same powers. Then they are like terms, and that means we can add and subtract them. So this next one, we've got this term 5x squared, and we're asked to identify these different pieces. The numerical coefficient is the number in front of the variable. We have a variable of x here, so that goes in the variable space. The number in front is known as the coefficient. And the exponent is the power on the variable, which in this case is 2. That's an x squared. This next example says to classify each as a monomial, which means one term, a binomial with two terms, or a trinomial with three. Well, this first one is a binomial. Terms are separated by either a plus or a minus. There are two terms there, separated by a minus sign. That makes it a binomial. The next one is a trinomial. It has three terms. Right, the first term is 3m squared. The next term is the 6m. The last term is the 11. They're separated by either a minus or a plus. And the last one is a monomial. There's only one term there. It doesn't matter that there are two variables. There's no plus or minus in between any of them. It's all part of the same term. So that makes it a monomial. So we're going to see different ways in which we simplify expressions with polynomials. And the first thing we look at is adding and subtracting. And as I said earlier, you can only add and subtract like terms. So that first term is a 2x. We can only combine that with other terms that have the variable x, also with the power 1, the same power, which is the minus 3x. Those two are like terms. They both have a variable x to the power 1, so we can combine them. We have a couple terms that have the variable y in them, y to the power 1. And we have a couple terms that have the variable z, or z to the power 1 in them. They are like terms, and only like terms can be added and subtracted together. If you have 2x and you take away 3 x's, that's going to leave you with negative 1 x's. If you have 2 of something and you take away 3, you're in the hole. You've got negative 1 x's. If you have 3y and you take away 5y, 3 take away 5 is negative 2. This is why we reviewed our work with integers yesterday. And the last ones, negative 7z's plus 10z's, negative 7 plus z is plus 10, is positive 3. And so there's a simplified expression. We went from 6 terms down to 3. We simplified it. Now, question B isn't much different. The only difference is that you've got brackets around one trinomial and brackets around a second trinomial. But you're adding those two together. And when you have a plus sign in front of the bracket, nothing changes. The 5a is a positive 5a, that doesn't change. The 12a is a positive 12a, that doesn't change. The 4b is positive, that doesn't change. The 6b is negative, that doesn't change. The c in the first bracket is negative, that doesn't change, as well as the c in the second bracket. Negative 7c's doesn't change. Whenever you have a plus sign in front of a bracket, it changes nothing, meaning all those signs stay the same. So now we can combine the like terms. 5a and 12a give you 17a's. 4b take away 6b is minus 2b's. And negative 1c take away 7c is negative 8c. Go back to your rules that we learned yesterday about integers. If you have negative 1 and you subtract 7, you can also say it's negative 1 plus negative 7. Add the opposite. Gives you negative 8. What's different about question C and D, though, is that there's a minus sign in front of the second bracket. And remember, when we were dealing with integers, we said subtracting is the same as adding the opposite. That's what we're going to do here. There's no sign in front of the first bracket, which means it's a positive. And that means when you remove it, nothing changes. But there's a minus sign in front of the second bracket, so we're going to add the opposite. And subtract, instead of subtracting an 8m, we're going to add a negative 8m. And instead of subtracting a 1, we're going to add a positive 1. A negative sign in front of the bracket changes all the signs inside. 8m was positive, it now becomes negative. The 1 was negative, it now becomes a positive. So now I will collect my like terms together and then simplify. 6m take away 8m. 6 take away 8 is negative 2m's, and negative 4 plus 1 is minus 3. So there's our simplified expression. For question D, there's no sign in front of the first bracket, which means it's a positive. And when you remove the brackets, nothing changes. But in front of the second bracket, there's a negative. That will change all the signs inside that bracket. Again, this is the same as what we learned about integers. Subtracting an integer is the same as adding the opposite. So we're taking the opposite in each case. I'll collect my like terms together. In this case, the a squareds are like terms. We can combine those, and then the a's are a different set of like terms. Like terms have the same variable with exactly the same exponent. You can only add a squareds and a squareds together, as well as a's and a's together. And I say add, but it's the same as subtraction. If you have 4a squared and you take away one of those a squareds, that leaves you with 3a squareds. Negative 2a plus 6a is positive 4a, and negative 5 take away 7 is negative 12. And there's the final simplified answer. Yes, sir. Yeah. Make sure you sign out, eh? The QR code. All right, try those next ones on your own, and then we'll check them. Yeah. So for that first example, there were plus signs in front of both brackets, so when we remove the brackets, absolutely nothing changes. All the signs stay the same. Always a good idea to collect your like terms. The more shortcuts you take, the greater chance you're going to make a mistake. And then you can combine your like terms to get your simplified answer. 4m plus 5m is 9m's. Negative 2n take away 6n is negative 8n. And negative 1p plus 4p is positive 3p. Notice when you add and subtract, the powers don't change. They only change when you multiply or divide. We're not doing that. For the second one, you have a negative in front of that second bracket. That'll change all the signs inside that bracket. The 5b squared becomes negative. The 8b and the 2 both become positive. The signs change. Collect my like terms together and then simplify. 2b squared take away 5b squared. 2 take away 5 is negative 3b squared. 1b plus 8 more b's gives you a total of 9 b's. And negative 3 plus 2 is minus 1. So there's the final simplified answer. Example 3, you want an expression for the perimeter of that quadrilateral. The perimeter is the distance around. You add up all of the sides. So P, the perimeter, would be found by adding up all the sides. 2b plus 5. I'm going to work my way around clockwise. I have a 3b plus 1. I have a 2b take away 3. And I have a 2b plus 4. If I collect my like terms together, that means that all the b terms and all the numbers, all the integers. Two and 3b gives us 5, plus 2 more is 7, plus 2 more is 9b's. 5 plus 1 is 6, take away 3 is 3, plus 4 is positive 7. There's our final simplified answer. It's simpler than the original expression, right? We went from 8 terms down to 2. Simpler. So for this one, these lines that are on the two sides mean that they are congruent, they're equal. If the one on the left is 5m plus 4, the one on the right would also be 5m plus 4. And again, we want the perimeter, so we're going to add up all three sides. And it's true, we could say, well, we could multiply the 5m plus 4 by 2, but we haven't really talked about multiplying with polynomials yet. We're going to get to that. So let's keep to adding and subtracting. So we'll collect our like terms together, all the m's, m to the power 1, and all the integers, 4, 4, and 3. So this gives us 14 m's, 4 and 4 is 8, plus 3 is 11. Okay, so we'll stop there. I've got an assignment for you to work on. I will post the solutions to Google Classroom. The expectation is that you do all the questions and then you check on Google Classroom to make sure you do things correctly. Talked about this yesterday. This is a significantly harder course than the last one you took, whether it was Math 9 or Math Competencies. We're going to learn a lot more than you had to learn before. And so the best way to do that, to remember it, is by doing the practice. So do the assignment, check your answers on Google Classroom. If you have questions, all you have to do is ask. Okay?